Okay, hello, my name is Nikola Varicak. My student number is 101432361. This is assignment 3 for Comp3132. So I'm going to be answering questions 1 to 3 here. Question 3, did the network present signs of overfitting? If so, in which epoch? Yes, it did present signs of overfitting. It started around epoch 25, where the accuracy plateaued, and it started going up. Or the testing accuracy plateaued, and it started going down as the training accuracy started going up slowly, which means it was memorizing the data and not actually properly training itself. How many layers this model has? This can be seen right here. It has 5 layers, the Conv2D, max pooling 2D, flattened, dense, and dense 1 layer. That is 5 different layers. What each layer does: the Comp2D layer extracts features like edges and textures using filters. This helps the model learn spatial patterns in the image. The max pooling 2D layer reduces the spatial dimensions, decreasing the overall computation and helping prevent possible overfitting in the model. Flatten, it transforms the 2D matrix of features into a 1D vector to feed into the fully connected layers. Dense 128. Learns complex relationships between features and contributes to decision making. And dense 10 is an output layer using softmax activation function to classify input into 1 of 10 categories. Yep. Okay, so for question 6, add 1 or more convolution layers to your model and run it again. So here, as you can see, we added the new convolution layer with the activation ReLU function and max pooling layer. Here we compile it, and then we train. Took a little while. This is what the end function looks like. As you can see, the training accuracy keeps going up and the testing accuracy starts going down, which shows a little bit of overfitting. But okay, number 7, compare the results between the original model made using Keras sequential vs the bigger model with at least 1 extra layer added. The larger model with an additional Comp2D and max pooling layer generally performs better on training accuracy and sometimes on validation accuracy too. It learns more complex features due to the increased depth, generalizes better early on. And add a dropout layer, right? Compare the result with the previous one. Right, so we added a dropout 0.5 layer right here. The main purpose of this is to reduce overfitting. Without dropout, the model can become too confident and memorize specific patterns in the training data, which hurts its performance on new, unseen data. So by dropping random neurons, dropout forces the model to learn redundant paths and become more flexible. Now where's the result plotting? So these are the results. You can see that compared to the previous model, the gap between training accuracy and validation accuracy is much smaller now. That means that the model is generalizing better instead of just memorizing. And even though the training accuracy might be slightly lower, the validation accuracy is more stable, and that's what we want. So yeah, as you can see, it's a big difference. Um, question 9, explaining your algorithms with the purpose of the dropout layers and how it works. So basically, a dropout layer is used to reduce overfitting. It works by randomly setting some neurons to 0 during training, and that prevents the model from becoming too reliant on specific ones. This encourages the model to learn more distributed generalizable features and helps it perform better on unseen data. Thank you for watching. That was my video. Have a good day.